Okay, let's look at 2001. Step 1, question 8. So, differential equation question. So, given that y equals to x, y equals to 1 minus x squared, satisfies that, well, should our px equals that, qx equals that? Okay, well, simple. Just chuck it in essentially, right? Because, px and qx, you get simultaneous equations in them. Because I have two solutions to the differential equation already, right? So, let's say I have a y equals to x. Well, then for obvious reasons, dy by dx equals to 1, and d2y by dx squared equals to 0. Yeah, and same thing for y equals to 1 minus x squared. So y equals to 1 minus x squared. So dy by dx equals to minus 2x. Sorry for the inconsistent notation, but you get what I mean. Y double prime is minus 2. Okay, let's sub that in. So we get simultaneous equations. Px times 1 plus qx times x equals to 0. And second equation, minus 2 plus p of x minus 2x plus qx of 1 minus x squared equals to 0. Lovely, good. Okay, so I suppose what do we want to find? Well, let's go px equals to minus x times qx, okay, just by substitution, yeah? So sub in px into the next equation. So I've got, so minus 2 plus minus x times qx. Okay, this is just standard procedure, right? You'll get boring, you'll get bored by looking at me doing this, and I'll make a mistake somewhere. So minus 2 plus 2x squared qx plus qx 1 minus x squared. Get the 2 to the other side. So this becomes 2 equals to 1 plus x squared times qx, which is as required, right? So qx is indeed 2 over 1 plus x squared, which was what the question wants here. Yeah? 2 times 1 plus x squared to the minus 1. Okay, good. And find px, right? So from this equation, I know that p of x equals to, well, minus x times that, right? So minus 2x over 1 plus x squared, which is also as required. Okay, lovely. Good. Okay, so as usual, let me erase it to get space. So now let's look at the second part as well. So show that ax plus b times 1 minus x squared satisfies the blah 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 differential equation. Okay, well, if it satisfies it, well, we just have to chuck it in, right? We just have to chuck it in. So let's go for that. So firstly, let's say y equals to that, right? Y equals to that. So which implies dy by dx equals to what? Differentiate once becomes x minus 2bx, right? And differentiate twice, d2y by dx squared, that should be minus 2b. Okay, so I mean it's just a standard procedure, just chuck it in and then do the mathematics properly, really, right? If you do the mathematics properly, then it's fine. So left hand side equals to minus 2b plus, well, px is this. I prefer to use fractions instead of the negative index minus 1 because I think it's really annoying. This is much easier to see, I think. Times dy by dx, which is a minus 2bx plus qx of y, which is, that's a really long expression, which is really annoying, plus b minus bx squared. Okay, well, it might be sensible to put it over a common denominator, right? Let's put it over 1 plus x squared, shall we? 1 plus x squared. So I have got minus 2b minus 2bx squared. And what next I've got here? Now I put the minus into there, so I get 4bx squared minus 2ax, I suppose. Something along those lines, yeah? And I've got plus 2ax plus 2b minus 2bx squared. Good. Does that go to 0? Let's see. Well, the 2b's cancel, right? The 2b's cancel, 2ax's cancel, and the bx squares also cancel out, which is 0, right? Equals to the right-hand side. Lovely. Good. So that proves that, that solves the differential equation, right? Because the right-hand side is actually genuinely 0. Okay? Good. Okay, now, next bit. Given instead that y equals cosine squared and y equals to sine squared, satisfy the equation. Px, qx actually is just same procedure, right? Same procedure as the first part. Okay, so let's go. Just differentiate properly. Then you'll be fine. Okay, so okay, I have to erase this. It's annoying when you have limited space, especially as a mathematician. So y equals to cosine squared x squared over 2. How do I differentiate that? Well, you have to chain rule twice. Okay, so make sure you do the chain rule properly. Okay, so first thing is, well, I do the 2 first. Okay, and then differentiate inside, which is minus sine x squared over 2. And there's still one more inside, which is differentiating the x squared over 2, right? So we multiply that by x. Okay? Alright, now what does the first bit look like? Oh, that should be y prime, shouldn't it? Okay, that's bad notation. This is y. This is y prime equals, right? Okay, that's really bad habits from me. Okay, so y prime equals that. Good. What does the first bit look like? 2 cosine something sine something. That is just the formula for the double angle of sine, right? So y prime is actually just equal to what? Equals to minus sine of x squared times x. All right, let's put the x in front just for the prettiness of the expression. Yeah, okay, so that's for cosine squared. Now let's do the same for the sine squared. Again, okay, I did my bad habit again. Y prime equals to 2 times sine of that times cosine of that. And again, by the chain rule, I need the x behind. Yeah, so this is essentially x times sine x squared by the same logic. So now you realize that these two expressions actually are just the negation of each other. So if I differentiate 2 times, let's do this one first. Well, by the product rule, I'm just going to skip over the differentiation steps, yeah, because I'm sure we can differentiate at this point. This should be minus, let me do this accurately, minus 2x squared cosine of x squared, right? Hopefully that's correct. So for this one below, it's just a negation of that, so it's just sine x squared plus 2x squared cosine x squared. Yeah, okay, and the remaining job is to chuck the expressions back into the differential equation, yeah, which is really annoying actually, because cosines and sines don't look nice, essentially. All right, so let's do that. So what have I got? Provided that my pen does something properly. Yep, there we go. So, well, minus sine x squared minus 2x squared cosine x squared plus px times the dy by dx. Oh, this is so annoying. Genuinely annoying. Plus qx times y, qx times cosine squared x squared over 2, that equals to 0. And the next bit, sine x squared minus 2x squared cosine x squared, plus 2x squared cosine x squared, sorry, plus p of x. Okay, I'm sorry for having you to look at me do algebra, but I'm afraid that's step questions sometimes. Equals 0, good. So how do we do this? Well, we know that these are negations of each other, right? So why not add the equations to make life easier? Okay, add the equations, we have qx equals to 0. Okay, that's one of the most pleasant things you can ever get, right? Cosine squared plus sine squared is 0. No, it's 1, so qx equals to 0. Okay, thank God, right? Okay, qx equals 0. Now, let's take the second equation, say. So sine of x squared plus 2x squared cosine x squared plus p of x sine x squared equals to 0. All right, so p of x equals to, well, the top is minus sine x squared. What is it? Minus 2x squared cosine x squared, yeah? Or over, let's put the equals to 0 slightly to the right hand side. Or over, what is it? X sine x squared. Okay? And if you really want to make this expression look nice, I suppose you could go something like minus 1 over x, maybe minus 2x cot x squared, I suppose. Something like that, yeah? Good. Okay, so hopefully that was correct. Maybe if I made an algebra slip somewhere, you guys corrected them yourselves, yeah? So, okay, there we go. Not the hardest question actually, but just not lots of computation, right? So the algebra is also annoying. Okay, cool.